Hi, welcome back. Today we're going to be looking at integrals, but more specifically, the first fundamental theorem of calculus. So what this theorem states is that if you have a definite integral from a to b of a function f, it can be evaluated using the antiderivative, so big F, of the top limit, so b, minus the antiderivative of the bottom limit, a. So big F of b minus big F of a. So let's look at a problem that might involve this theorem. So here's what a question using the first fundamental theorem of calculus might look like. So we're given a graph of f prime of x, and we're also given some piece of information about f. So this function f would be the antiderivative of this function f prime. So we know this is the graph of f prime, and we know that on the graph of f at the point 1, the y value is 3. So f of 1 equals 3. And we're asked to find what f of 5 is equal to. So using what we know about integrals in the first fundamental theorem of calculus, we can figure this out. So we know that an integral is the area under a curve. And this right here, this graph, is our curve in this situation. So what we're going to do here is set up an integral from this point here, because we know what f of 1 is. So from 1 to this upper bound, which would be 5, of f prime of x. And now what we're going to do, using what we know about the first fundamental theorem of calculus, is say that, well, this integral is really equal to f, which is the antiderivative of f prime, of 5 minus f of 1. So now that we have that, f of 5, or that integral is equal to, f of 5 minus f of 1, what we can do to solve for f of 5 is we can plug in information we know. So first, we know what f of 1 is equal to. It's equal to 3. So we can already rewrite this as f of 5 minus 3 equals something. And now to find what that something equals, we have to look to the graph. Because remember, originally we had the integral from 1 to 5 of f prime of x dx is equal to this. But the integral from 1 to 5 of f prime of x dx is also equal to the area under the curve of f prime from 1 to 5. So let's look at that. Let's say this point here is 1. We'll draw our little dotted line. And then over here we have 5. So what is the area under the curve of f prime from 1 to 5? So we can split this up into a few parts to make it easier. First, we can split it here. Then we can split it here. And we can see that this rectangle is 1, right? Because 2 minus 1, so it has a length of 1, or a base of 1, and a height of 4. So the area of this rectangle will be 4. The area of this rectangle over here is 1 times 2. So the area will be 2. And then we can make one more rectangle here that'll have a height of 2 and a base of 2. So the area will be 4. And then finally we have to find the area of this triangle. So it has a height of 2, or rather, a base of 2 and a height also of 2. So 2 times 2 is 4, divided by 2 is 2. So 4 plus 4 is 8, plus 2 is 10, plus 2 is 12. So we know that the integral from 1 to 5 of f prime of x dx equals 12. And if we know that this equals 12, and this integral is equal to this function here, we know that this is equal to 12. And now we can solve for f of 5. So we just do some algebra, flip this -3, make it positive, and we can find out that f of 5 is equal to 15. And that would be our final answer. So that's what a problem using the first fundamental theorem of calculus might look like.